All right, so apologize for that. Sometimes Zoom goes missing on me. So, hi, I'm Jay Arthur, author of Lean Six Sigma Demystified, Lean Six Sigma for Hospitals, Agile Process Innovation, and QI Macros. And I've been in quality now for about 30 years, since 1990. So I've lived through many iterations of TQM and Six Sigma and you name it, and Lean coming together with Six Sigma. And so now, in the last 20 years, I've been going at it a little differently, and I've noticed that people are discovering how to use Six Sigma in service industries to get results in 1 or 2 days. 1 or 2 days. All right. So my goal in the world is actually to get this going in a way that's truly appropriate, I believe, for how we do business in the future. So can you see my learning objectives screen? Just checking.
Yes.
Okay, good. All right. So here's the idea. Is companies out there are stumbling onto the Agile approach to implementing Lean and Six Sigma. And they're succeeding where traditional implementations have failed to deliver results. Failed. All right. So I think the way we've approached Lean and Six Sigma was a manufacturing orientation, not a service implementation. And you can even see that in terms of a membership in like the American Society for Quality. It's predominantly oriented towards the manufacturing world. They have very few, maybe 10% of the membership are actually in service industries. So this new way will help you identify the best candidates for your black and green belt trainings. And there's 7 key tools that I think will solve most problems. And you can learn how to teach Six Sigma in 1 day and generate results. Now, when you think about the 2-week and 4-week green and black belt programs we talk about, that doesn't sound possible, but it is. So back in January of 2017 in the Harvard Business Review, this gentleman said, Six Sigma is too complex and time-consuming to fit into a regular work day. We need tools that don't require an entire organization to undergo weeks-long training programs. This is the Harvard Business Review. All right, people listen to what HBR says. So I want to look back at 20th century quality improvement. So the American Society for Quality was founded in 1946. And manufacturing and service industries were neck and neck, and farm industries had been declining since the 1900s. And so back when we started, it really focused on manufacturing because that's where the need was. And our traditional Lean and Six Sigma training starts with big binders. If I was in my office, you'd see a whole bookcase full of binders, right? And 2 to 4 weeks of training gives you a green belt or a black belt. And then, it could take months to get a project done. I saw one presentation by 2 consultants who taught Lean and Six Sigma, so I think they were a little biased, but they said most Six Sigma projects we studied it, and it takes 4 to 16 months to get results. That is just nonsense, all right? And the other thing they mentioned is that most people go through a green belt or a black belt training and they do one project. In the industry, this is known as one and done. One and done. Now, if you spend 4 weeks training somebody and only get one project out of them, you've lost money, all right? You have lost money. So how do we get people engaged in quality improvement? One of my things is I'd like to create a hassle-free world, hassle-free healthcare, right? I'd like to get to zero harm. I work a lot in healthcare, so I'll give you some healthcare examples. So how do we do that? How do we get results in 1 day? Well, I believe that the secret to this is there's a long tail of Lean and Six Sigma tools that are used rarely. And then there are a handful of tools that are used a lot, right? And if we teach people just that 4%, right? This is part of Paretos rule. Just the 4% of the tools that are going to solve most problems, we can start getting results and we can start getting them quickly. And so I think, in our green and black belt trainings, we teach the long tail of Six Sigma tools. In healthcare, I've seen people that actually taught gauge R&R and measurement systems analysis to healthcare professionals. They don't use measurement like they do in manufacturing. Teaching that is stupid. All right. They don't use design of experiments. They don't use a lot of the things that are in the long tail. Now, if you work in manufacturing, yes, you are going to need the long tail of tools, but in service industries, you are not. So here's what's happened in the United States of America in the last probably 70 years. Service industries are now 80% of the employment, 80%. Manufacturing, real manufacturing is only about 8%, but total manufacturing related things are 13% of employment, and farm employment is 2%. So what does that tell us? That tells us that the opportunities are in service industries. Manufacturing in the USA is a $2 trillion industry, and healthcare is a $3 trillion industry, right? And that's just one of many service industries that are out there. So here's what I've come to observe, all right? And this is just me talking about 30 years of watching stuff. There are simple problems that can be solved with trial and error, right? You don't need any advanced tools. And all too often, I see people go through their Six Sigma green belt or black belt training, and then they try to use Six Sigma on a problem that's so simple, they already know the answer because they want to prove to themselves that the methods and the tools work. That's dumb, okay? Right? We should take the tools of quality and hit things that are important and things we're struggling with. Now, at the very high end, there are complicated problems, and maybe we need full-blown DMAIC and DOE, and we need more complex like design of experiments. Maybe we need gauge R&R, maybe we need a lot of other things, quality function deployment. But that's not where most of the problems are. There are what I call uncomplicated problems, but they require some data and what I call the 7 key tools, right? The 7 magnificent tools. Now, this is related to what we know in quality improvement. And the method is really, we're just going to use data to focus our attention, make the improvement, and then sustain the improvement, and then honor our progress and repeat forever. All right, because you're never done. Unfortunately, you're never going to be done. So the vast majority of problems are uncomplicated, but need key tools to get them solved. So how do we do this? Well, we're going to take hacking. We're going to hack Lean and Six Sigma. And so the spirit of hacking can be adapted and applied to general business management, not just technical innovation. And Harvard Business Review, again, had a whole issue dedicated to Agile methodologies. Now, Agile came out of software. And what did software do? Well, they borrowed the principles of Lean and applied it to software. Duh. And then they gave it a better name, like Agile, right? Think about the phrases. Would you rather be lean or would you rather be agile? When I think agile, I think cheetah. When I think lean, I think somebody who's malnourished. All right. So that I think there are things that we can do. We can change the language. We've been living with 100 years of language that just does not help us that much. So how do we hack? So one of the things I do with QI macros is I go exhibit at all these conferences. And I go to presentations to see what people are doing. And in the last 3 years, before COVID, that's BC, right? Before COVID, I attended some Lean Six Sigma conferences, and this is what I found. So at the American Society for Quality, or ASQ as it's known in the trade, I saw a presentation by Christus Health. And Christus Health had implemented what I call Big Sigma, where they had green belt and black belt trainings, and by golly, guess what? They were not getting the results they thought they should get. So what did they do? The leadership team came down to the training people and said, we want you to figure out how to train people in one day and get some results. And Christus Health said, well, what, I don't know if I can even do that. So what they did though is they went ahead and they followed kind of this prescription I've had for a long time about how to do this. It's called Agile Lean Six Sigma, and I'll give you a link. You can download my book about this later on. All right. Now, Christus Health said, okay, well, let's do a 1-day training. And we can't teach them everything, so we're only going to teach them the tools they need. But to get results, we're going to have to bring in teams. And so to get into the training, you had to have a team of people with real data about a real problem that needed to be solved. No data, no team, no go. You don't get to go get trained and add that to your resume. That's not how this works, right? And so your goal was to actually get people who had data about a real problem and bring them in, teach them the tools, and then solve it and implement those improvements. Now, guess what? They did this and they started to get results, right? They started to get results. And the other thing that they noticed out of this process was some people just loved quality improvement. They loved the tools of quality. They loved solving problems. Guess what? Those people are ideal to send on into green belt and black belt training because the advanced training will make sense to them. But the other people, one and done, right? But they've been dipped in the tools. So, maybe out of 20 people and 4 or 5 teams in a training, maybe 2 people would come out of that should really go on and get advanced training. Now, at the same conference, I saw Novartis, which is a drug manufacturer, and they were having trouble getting samples out to doctors. And so their whole process was they sat down and said, well, let's see if we can't do this in a couple of days. And so they did. They brought in people who had everything to do with getting samples to doctors and brought them into a room for 2 days, taught them some tools. And the first day they taught them the tools. The second day they worked on the problem, then implemented the problem and collapsed the cycle time to get samples out to doctors and to sales reps. 1 or 2 days. This is 1 or 2 days got results. At another conference, there's another conference out there. I saw a presentation by Crayola. Crayola did very much the same thing. 2 days. 1 day is teaching them process and tools. 1 day is working on the problem. And you had to have a team with data that had a problem to solve. No data, no problem, no go. You just can't go to training, right? You have to come in and solve a problem. Same thing, and they started getting results. So these are companies reporting this whole process. And at the same conference, I saw Underwriters Laboratory, and they're spread out all over the planet. There's like 14,000 employees across the world. And so, of course, this would not work, right, to bring people together too easily. So what they did was slightly different, which is they had teams in different locations with data and whatever, and they do 1 day of online training, right? And so that online training could then be used. And then the next day, they would have local meetings anywhere on the planet with the teams with the data to solve, and they'd be facilitated through getting results. And guess what? They started getting results. All 4 of these companies in about a 1-year span that I saw them reported that 1 day of training or 2 days of training focused on teams that had a problem got results. Hey, this is cool, right? That's what we want. Leadership wants results. You don't get results, you're not going to be here very long, right? And I was part of a quality improvement group at the phone company. I worked at US West, which is one of the baby bells here, back in 1990. And they cranked up a whole total quality management thing because that was before Six Sigma really got traction. And what happened was after about 5 years and not much progress, they shut down the department and laid us all off. Now, I'd been working with the VP of Finance, and I helped her save $20 million in postage and $16 million in adjustments. I walked back from that meeting after being fired, and I was depressed, and the phone rang, and it was the VP of Quality. I mean, a VP of Finance, and she said, "Hey, I want you to come work for me. I think you're a free agent now. Come work for me." and which I would have done if she was going to be around. She was a 30-year veteran, so she wasn't going to be there that long. But I went out on my own and started doing consulting and ended up creating QI macros. So I'm telling you, if you learn how to get results quickly, then you're going to be in a position to get leadership's engagement, right? And leadership will help pay for things because then you'll know who should be a green belt and who shouldn't. So here's what it looks like. There's pre-work. So you have to select teams that have a real problem to solve and data about the problem. No data, no go. And I will tell you, most companies, if you look at the DMAIC thing, it says, well, define the problem, then get some measurements, then blah, 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 blah. That's just wrong. Okay. Every company has more than enough measurements about what's going wrong. Go find the data that already exists. Do not try and create new data. That's just dumb, right? At some point, when you solve all the problems that have data, you'll figure out what better measurements should be, but you will not know when you start. And all too many people try to go, well, we need to survey our, no, stop, right? Go find real numbers about real problems and solve those things, right? So we're going to do we're not going to do the D and the M phase. We're going to do analyze, improve, control, analyze, improve, control, right? And repeat that until we run out of data that supports that. All right, so we're going to get teams together that have a real problem to solve and data about the problem. Then in one day, you can train teams in the key improvement tools and get them to apply the data to their data and the problem, and then come out and implement the countermeasures and measure results. So your investment is one day to get results. And very often teams will get results. They're facilitated by somebody who knows what they're doing, but you get the idea. This is how we hack Lean and Six Sigma to get results in one day. And I actually have an Agile Lean Six Sigma trainer training, and I'll point you to that on our website where you can actually learn how I teach this. So when it comes to hacking, how we hack Lean, well, you start in by doing a value stream map or a spaghetti diagram, and you shrink the arrows. Because in any service industry, unlike manufacturing where the machines are all connected, right? The delays are in between steps. It's in the arrows, right? 90% of the delay in any service industry is in the arrows, not in the activities, right? People are only working on the product or service for 3 minutes out of 60. The other 57 minutes are for delay. And so when you start to collapse the arrows, guess what? You can get big results in a big hurry, right? I worked with healthcare teams, and I'll show you that in a minute, but we collapsed the amount of nurse travel by 50, 70% and did it in a couple of hours. So this is not rocket surgery, right? So here's some nurses value stream mapping, right? And so here's our advanced technology for Lean, right? This is activities. These are the arrows. If you put times on the arrows and times on these things, you'll discover that one or two of these little arrows suck up 90% of the total time. 90% of the total time in a service industry. In manufacturing, maybe not so much, all right? But this is where the big thing is in a service industry. So what can we do, right? So once you value stream map something, here's a spaghetti diagram of a nursing unit. So this was the original, took about an hour. Here's the revised, took about an hour. And then I just sent them back to their nursing unit to reorganize things, right? 2 hours to cut nurse travel time and cycle time and by 50% and increase time with patients, increase nurse satisfaction, patient satisfaction, all kinds of things get better, right? I worked with one company that was trying to design rural hospitals. This was a architectural company, and they'd been doing hospitals forever, but their customer said, I want a lean hospital. And they were going, oh, I don't know what a lean hospital looks like. And I said, well, let's get some Post-it notes and lay out in a spaghetti diagram what a lean hospital would look like. And most lean hospitals are flat. And I said, well, why don't we, since the amount of patients goes up and down during the course of a year. They call it census. So it goes up in the winter when everybody gets the flu, goes down in the summer. Well, why don't we just arrange it so that it's a vertical stack of patient rooms, and you could potentially shut off levels so that you don't have to air condition them or support them or anything else until you get the load that you need to open those back up. And we could set it up so things travel more quickly, and blood samples can get to the lab so that we can get to results, that we can get patients discharged, right, or admitted, one of the two. So I've done a lot of things with Post-it notes that people thought were impossible, but you can do it in a couple of hours. So this is another spaghetti diagram of a nursing unit. Look at how much travel time there is for all these nurses. When we redesign it, we cut it in half. They spend more time with patients. So that's how we hack lean, right? Is we focus on the one thing that is causing most of the delay, is the arrows between things, right? Watch your product. It's lazy. It takes long breaks. It goes out for long lunch hours. It goes on overnight trips. The delay is the product. So stop watching people. If you made your people twice as fast, you'll only save 1.5 minutes out of every hour, right? So let's not make people faster. Let's make the product of the service faster. All right, so that's how we hack lean. And now, how do we hack Six Sigma? Well, what we're going to do is use a series of tools in a certain order to get the results. And so one of the things that I found is invaluable is a pivot table. And a lot of the data you have is raw data about mistakes and errors and events and whatever it is. But most people, we don't teach pivot tables in Six Sigma, right? We teach a bunch of other stuff, but we don't teach you how to turn raw data into something we can then chart. And I'll show you how to do that. So then we're going to come up with a control chart, which is our baseline for how it's working now. Then we're going to take Pareto charts. Or if you have time data, you might use histograms. Most of the time I'm doing Pareto charts. And then the big bar of the Pareto chart becomes the head of the fishbone. So the big bar becomes the head of the fish. Then we do root cause analysis. Now, let me explain to you something I've learned. In my training, they said, well, just get some people together and brainstorm ideas. And once you've brainstormed ideas, then you start gathering data and start measuring. Oh gosh, no. All right. If you start from data, if you start from raw data or just data that's been summarized, get a Pareto chart and create a fishbone, it is only at that point that you know who should be on the team. Only then. You do not know who should be on the team until you've narrowed the focus down quite a bit. And I'll talk about what I call going from the 80-20 rule down to J. Arthur's 450 rule, right? How do we narrow that focus so that we can get results in a timely fashion? And then we're going to come up with an action plan, countermeasures, and then we want to measure, did we improve? And from a Pareto chart perspective, did we reduce the number of errors? Or from a histogram perspective, did we bring everything into our spec limits? Now, these are part of what I call the Magnificent 7 tools. Now, one of the things I do, I go to these quality conferences and I look at poster presentations to see what kind of tools are they using. This is the Institute for Healthcare Improvement Conference. Most of the time, they're using line and bar charts with trend lines through them. And the trend lines have no goodness of fit metrics, so most of these are hooey. There are some control charts and fishbones and Pareto charts, maybe a run chart or two. This is Magnet, which is another healthcare quality conference, line and bar charts. Very few Paretos, control charts, or fishbones. National Association of Healthcare Quality, line and bar charts, a run chart, a control chart or two, or Pareto chart. And I've seen this also at ASQ. I don't know if I have the ASQ in here. Yeah, but at ASQ, the poster presentations were mainly line and bar charts. I'm sorry, folks, control charts have been around for 100 years. Why aren't we using them? And I think it's because everybody thinks they're too hard. They're not anymore, right? There's software to do that, all right? Mine or somebody else's. But what you're going to need is some tools to be able to do the analysis. And if you don't have the tools, don't do the training because it's a waste of dang time. So let me talk to you a little bit about what's wrong with line charts. So these are what are called catheter-assisted urinary tract infections in healthcare. And I saw this thing, it had a trend line, but it did not have an R-squared value, which is how good does the line fit the data. And 0.30 is a 30% fit. Now, I don't know about you, but I would not want to stake my career on 30% fit, right? If we take that chart and drew it as a control chart, you'll see there was one out of control point early, but then this is actually a stable control chart. So they absolutely did not succeed at fixing anything, all right? And I see people at these conferences that are walking around looking at these things, and they've got their little camera out and they're taking pictures of improvement posters like these are cool, and we're going to go back and try and implement that. No, I think that harms patients, that harms hospitals, that harms whoever, right? If this is a bad improvement story and you take a picture of it and you try and replicate it, you are going to go out of your mind. Now, here's another one. This is another type of hospital-acquired infection. By the way, hospitals are fraught with problems, but we've seen more of that with COVID. But in general, this is BC before COVID, right? There's all kinds of other things. So here's the R-squared here is 0.53, so a little bit better than a 50-50 fit. Was there an improvement? If we draw this as a control chart, you can see there was a before, which is about 9, and the after, which was about 5. This actually shows an improvement. And so what do we want to do? We want to be able to show improvement. We were at a conference exhibiting across from the Baldrige examiners here in the States, and the Baldrige examiner was watching us do all these things, and she came over and she said, you know, a lot of people show us their before, but they don't show us the after. If you don't show the after, that you've made an improvement. And again, here we have a control chart, which means we can sustain that improvement. Then you got nothing, right? You can't prove that you've changed anything. And this is my argument for why everyone needs control charts, because the only way to sustain the improvement is in the control phase of DMAIC is to put in control charts to monitor the process. If it starts to go out of whack, then you fix it. I talk to a lot of people, and you know, they say, oh, we made this great improvement, and then 6 months later it was gone, right? We made this great improvement and 6 months later it was gone. And I say, well, did you put in a control system to monitor the performance with control charts? Well, no, we didn't do that. Oh, hey, you know, if you're not going to do the control phase of DMAIC, don't bother with the improve part, right? You're going to waste time. All right. This is an ongoing, consistent problem across every industry I talk to. Manufacturing, healthcare, aerospace, doesn't matter. Banking, everybody fails to put in the last step of DMAIC and actually chart their data. So if you're just using line and bar charts, I don't know if that's any good. But if you use control charts, histograms, Paretos, you can tell if your process is stable and capable. So let me suggest to you that most data that you see is overcooked. If it's been summarized in 2 weeks or months or whatever, like this data here, this is a type of healthcare data, but we've got Q1, Q2, Q3. This has very little nutritional value, right? You can't figure out what to fix here. What are the deaths caused by? There's not enough here to figure that out. So I'm going to encourage all of you to go on what I call a raw data diet. What does raw data look like? Well, at the very minimum, it says when, the where, and the what went wrong. So I'm going to go, this is QI macros. I'm going to get some test data here. And where's our data mining data? There it is. So in manufacturing, it might look like this. Oh, come on. I hate it when it tries to go off. I must have hit a magic button. Come on. View standard page view. I love it when technology helps me out here. But maybe you can see here that we're actually have by date, by production line, we have a type of defects. And we could go in here and count folded flaps, folded flaps, folded flaps, folded flaps. And I've actually seen people doing this with a little stroke tally or an abacus. You know, it's like crazy. Pivot tables will summarize this data for you. Could be something that looks like this, lost time analysis. It could be nursing unit defects, by date, by nursing unit, type of patient harm. Could be denied insurance claims. So this is one project I worked on. I'll show you. This is what the data looked like when we started. Type of ICU sedation medications, patient falls. These are all things that is, here's the when, the where, and the what happened. This is what this data looks like. And then if you have the how much or who or why, that'd be great. So again, you're going to have data that looks like this. This is the denied claims data by entity, by hospital, by admit date. What are the denied charges? So this is the where, the when, what happened, and how much did it cost? That could be worth $5 million a year. I worked on this project, right? So it saved a ton of money. If you have data that looks like this is scrap data from a manufacturing plant. So where did it happen? This is the type of machine. When did it happen? What was going on, and how much did we lose? That was worth $1 million a year. So let me suggest to you that your consultants or trainers always talk about low-hanging fruit. And I'm telling you, I have an apple tree in my front yard, and it was easy to get the low-hanging fruit, and that's usually picked, right? And I encouraged the neighbors to come help because I had a bumper crop this year. But I call it invisible low-hanging fruit lives in data that looks like this, right? And so we're going to need to learn how to use pivot tables to turn that into an improvement project. So how do we do that? Well, you need some data mining wizardry. There you go. So we're going to take this raw data, turn it into pivot tables, turn those pivot tables into control charts and Pareto charts that give us the insights for action. And only once we've done that do we know who should be on the improvement team, right? Because we don't know before that. So let me show you. And let's go over there. So here we have date and line. You know, I could do it for nursing unit defects by date, by unit. And I'm not sure exactly who all's on the call, whether you're in manufacturing or service industries or healthcare or whatever. But I used to do this manually. So I would take this and I would insert pivot tables, and then I would manipulate everything, and so I could get to stuff. And then in 2017, I figured out I could automate this in the QI macros. And so in the QI macros, there's what's called a improvement project wizard. So all I have to do is select two headings. So I'm going to use date and line and click on improvement project wizard. Now the improvement project wizard is going to go out and create pivot tables, control charts if it can find them, Pareto charts if it can find them. It's going to try and do the high level 80-20 Pareto, then take the big bar of that and drill down and create what I call as a 450 Pareto. And once you can drill down to a 450 Pareto, you've got something you can probably solve, and then create a fishbone diagram. So here you can see what it did was here's the overall, it created a control chart, and then it found two improvement projects in there. So by line, you know, the one high level Pareto, then a lower level Pareto, then it created a fishbone diagram and created a problem statement from that. So down below here, you can see it created all of these charts and graphs. So here's our uh, packaging defects by line by date. And then we drilled down, who has the most defects? Well, it's line 3. And then we take line 3, drill down into that, and it created folded flaps. Oh, folded flaps are 39% of the total defects in line 3. And then it created a fishbone diagram. So during 2020, folded flaps accounted for 39.5% of line 3 defects. But it doesn't stop there, it keeps looking. So it goes in by type of defect, it'll look and it finds folded flaps, bent and damaged, carton will not open. And then it finds that line 3 is most of the defects folded flaps and creates a fishbone diagram. Now, I guarantee you, if you take this improvement story to a leadership team, they will free up people to solve it. Because line 3 is 79% of defects folded flaps, which causes problems with shipping and everything else, right? And so what this has done is said, I need somebody in line 3 who knows something about folded flaps and get those people, all right? I need those people on my team. I don't need people from line 1 or line 2. I need people from line 3, right, to solve this problem. And I will tell you, people do not like it when somebody else solves their problem for them, right? Even if I know the answer to team problem, right, what their countermeasure ought to be, even if I know what it is, I don't tell them, right? Because they do come up with it on their own. If they come up with it, they own it, and they will implement it. And this is painful, but it's a very, very successful thing. All right, so that's how we take raw data. Where's my data? So this is part of the pivot table. And take this data here and turn it into an entire improvement project. That's what your improvement project should look like. All right, so that's what we want to do. And then we can make improvements. Now, when I did this with healthcare, we started off with that denials. And so they were losing a little over $1 million a month to denied claims. And I always believe you have to apply what I call the 450 rule, which is, 80%, 20% of what you do causes 80% of the mistakes, errors, waste, rework, lost profit. All right, so here's our big 20%, but within that, the Pareto rule still applies, which means 4% of what you do is producing over half of the defects, mistakes, and errors. 4 steps. That's 1 step out of every 25. Creates over half the mistakes, errors, waste, rework, lost profit, patient harm, whatever it is. So our task is to use this raw data to pinpoint that step and fix it. And so in this case, we found that timely filing was 61% of the total defects and denials. And so then we drilled down into timely filing. Now, I used to do this manually. This took me about 3 days, and I can now do it in a couple of minutes using the wizard. But within timely filing, one insurance company was 64% of the total. This is the 450 rule at work, all right? And I see this repeatedly, all right? Repeatedly. And so what I want you to do is think that if I drill down just a little bit more, I can maybe get really specific. Now, teams always want to solve world hunger, and they want to boil the ocean, and unfortunately, that's a recipe for failure. Okay, so you come up with a fishbone diagram, but it has very little, a very small number of root causes. I mean, it's not a big Pareto. If you start whalebone diagramming something, that means you have not narrowed your focus enough. I don't know about you, but early on, we built a whalebone diagram that covered an entire conference room wall. That's how you know you're not narrow enough in your focus. So we came up with some countermeasures. They implemented, these are process changes. They implemented those countermeasures on a Monday morning and started saving almost $400,000 a month. And here you can see the before, and here's the after of what we did in terms of process improvement. Now, they went on to work on other things in here, and they saved $24 million in rejected claims. They eventually got paid, but being rejected delayed getting the money, right? That was slowed down the money. So lots of things were saved. So that's how we get to world-class improvements. Control charts, Pareto charts, a couple of levels of them, cause and effect diagram. Then we can show control charts, compare the control charts so we know how we did. So that's how we hack Six Sigma projects. And now I want to talk to you a little bit about how to hack Six Sigma training, right? So I found that people often spend a lot of time teaching people the formulas to calculate control charts. That's a dumb waste of time. Those formulas are centuries old and have been baked into every software tool out there. Mine, QI macros, any other tool you buy, but you're going to have to buy a tool. So teaching people this, waste of time. And I've seen people do it. And I also believe you don't need to learn the formulas. I don't think you should have to learn decision trees. And so what I did some time ago, again, this is me chasing, how do I make life easy for people, is if you have data that looks like this, these are falls per 1,000 patient days. If you select data like that, and again, this is different from everyone else. Most software asks you to pick a chart first, then pick the data, which means you have to have that decision tree in your head. If you do not have that decision tree in your head, you can't pick the right chart. And people worry about not picking the right chart and that somebody will pick on them for not picking the right chart. And out of that, becomes a very uncomfortable situation. And so people hesitate and they go back to drawing line and bar charts. So if you select the data with the mouse, I created what's called a control chart wizard. Now the control chart wizard has that decision tree baked into it. All right, so it'll go look at a single column of decimal data and go, that must be an XMR chart. So here's our X chart, which is the actual data. And then the R chart is just the difference between each of these two steps here, right? And so that'll give us that. And then we have any out of control points here. You can see are baked in red. So here's a couple out of sigma. Here's a downward trend. And so that maybe we had some issues and then we did an improvement project. How do we show that? Well, also, if you just click on the chart, the QI macros also is a chart menu. Now, I used to have people do show process changes, but hey, I created a process change wizard that'll look for trends and runs and go ahead and change those limits for you. So does this give you some idea about what is possible, right? So we can start to automate and make algorithms that make it easy for the average Joe or Susie to learn how to do this without epic week-long trainings. You may be used to using a decision tree to use the right control chart, but we built that into the control chart wizard so that people don't have to learn that. So I want this idea that we can automate a lot of things that we used to spend time training. So what do people need to learn to do? Need to recognize what patterns they're trying to achieve. So if you have a control chart, then you either need to reduce variation, so collapse that, so it's not as variable, or you need to move the center line up or down. Right? That's all we need to know. If you have something where your histogram is off target, we want to bring it on target. So we want it to move on target. That's our improvement project. If there's too much variation, maybe we want to reduce the spread. That's what we want to do. Now, what happens? Once people understand the patterns they're looking for, they are very good at solving that problem. And if you have too much cycle time, 0 is how long people want to do things. I think I used to say that people want you to be better, faster, and cheaper. And my boss used to say, well, I can give you any two, better and faster, but not cheaper, cheaper and faster, but not better. But that's not true. Everybody's gotten used to Google and Amazon and everything else and going, I want it free. I want it perfect. I want it now. That's the new standard, right? If I can get it perfect, I can get it now. I'll pay you for it, but otherwise, eh. So this is what we want to do: is reduce cycle time. How long do patients want to wait to see a doctor? 0, right? But very often it's much longer than that. So why do we need to pivot now to adopt an agile methodology? Well, I think because we're going to have to avoid extinction. The last century stuff, that was all about manufacturing and all these big, long greenbelt trainings and long projects, that's not going to fly. That is just not going to fly. So let's adopt an agile approach. So traditional, it was big implementation, rigid processes, blah, blah, blah. And small agile teams that focus using agile, accelerating speed and adaptability. Get some laser focus, data-driven projects. Make it simple, right? 1 day or 2 day trainings, 1 day to train, 1 day to work on the project, or do it all in just 1 day. And again, if you go to my website, qimacros.com, I have some free training on how to do this. So very often people start off with gut feel, common sense, trial and error, and a lot of leaders get promoted because their gut feel, common sense, and trial and error is better than average. But I can tell you, you can only get as high as a 1% error rate, or down to a 1% error rate, or about 4 sigma using those things. You'll never get to 6 sigma without using some Pareto charts, histograms, and control charts. And you could very quickly go to hassle-free quality, all right, to becoming what I call a money belt. Money belts are people who can use the tools of quality to save money, all right? So I hope you get this idea that it's possible to do 1 or 2 day trainings and get results. And then identify the best candidates for ongoing green belt and black belt training, people who can, matriculate and go learn even more and be even more effective. But trying to start and figure out who those people are in advance, good luck. And how other companies are starting to use this agile methodology to succeed where traditional implementations have failed. And the 7 key tools, right? Magnificent 7 tools, and get some ideas about how to teach Lean and Six Sigma in 1 day. So before we go there, I'm going to go over here for a second. So if you go out to our website, under free training, you'll see that I have video tutorials, free Lean Six Sigma training. My free Agile Lean Six Sigma training is out here. So you can actually walk through how I do this, right? What is it? And down here, you'll also find that you can download my Agile Process Innovation ebook, which describes how to do this in more detail, right? So, why do I give all this stuff away? I'll tell you why, right? Because there's only one of me, and there's no way I can train 100 million people, right? But I can train them online, and especially if I do it for free.